Particle has just released a new version of their device OS that allows us to put our temp sensor to sleep. Let's check out this new capability, update our firmware, and put our device on the bench and do some current measurements. Then, let's do some math on the battery I'm hoping to use with our sensor and see how long it should last. Okay, so before we get started in doing the power tests, the sleep tests for the Xenon, what I want to do is just kind of take you through the setup here. So essentially what I've done at this point is we have our Argon talking to a display, an OLED display. It's receiving communication from our Xenon here. The Xenon is attached to an MCP9808, which is our temperature sensor. And this is reading temperature readings every 5 seconds, transmitting it on the mesh network to a event that this Argon has subscribed to, and every time it gets a temperature, it displays it. I'm also displaying how long it's been since the last time I got a temperature reading, and I'm also displaying the RSSI value of how strong the signal is. Now, I'm using external antennas here, and they're literally right next to each other, so interesting that we're getting about those kind of readings as we go through the process. But the point that we have here is really jumping into doing power measurements. So right now, this is sort of running at about 4 milliamps, and then it fires up the radios, does a transmission. That's where you'll see it jump up, and then it'll come back down, and it'll settle out at around 4 milliamps again. So what we want to do is fill out basically this little spreadsheet here. So what I have is basically a column here for the NRF52840, which is our microcontroller, and we want to put in some numbers here that just show what the power is normally, just with it running without the radios, and then we'll look at going into two different types of sleep modes. So one of them is called stop mode, if you will, and that's where the microcontroller goes to sleep, but it can be awakened over a period of time, so the real-time clock can interrupt it, or we can set a specific pin or sets of pins that can also be interruptible, and if they are caught on a rising edge or falling edge, all of that can be configured. It will wake the microcontroller up. The other kind of sleep mode is deep sleep, and in the deep sleep mode, the only way we are going to wake up is going to be via an interrupt. So in our particular case, we're going to probably use the stop mode, but we have opportunities to use other modes as we go forward, and we'll explore those in some other videos. So if we look at the code that I have here, what I've done initially is I'm going to go through and comment out the code that is actually firing up our temperature sensor. And what we want to do initially is just get a reading of the system doing a delay. By the way, this constructor right here does not fire up the temp sensor and pull power. I've already tested that, so I'm going to just leave it here. But when we actually initialize it here, it would. And so when we do our measurements, I'm going to actually pull the power off of the MCP9808, and we will just be running with the microcontroller, and that will give us our baseline to compare these two sleep modes. So let's start out doing that. So what I'm going to do is I'm going to plug in USB to power here. I'm going to disconnect the enable line, and I'm going to turn the power off here, and we'll see that we're powered by USB. Put it into DFU mode, and then I'm going to flash this. Now, the other thing I want to do is I want to pull the power line off of my temp sensor, so it's disconnected. And so at this point, when we actually do our measurements here, we'll be looking at measurements that are purely just the microcontroller. So I'm going to go ahead and flash this to the microcontroller. Okay, so the microcontroller's been flashed. We're breathing white because we haven't fired up any radios. I'm going to disconnect the USB. I'm going to set the enable pin low. I'm going to turn this on. and we are now running off of the external power off this power supply at 3.3 volts. And we can see that we're pulling around 4 amps, and so, or sorry, 4 milliamps. So we could do math. Let's go ahead and do average on, and we'll see kind of where this settles out. So it looks like in its just normal state of running without the radios on, it looks like it's about 3.9 milliamps. So we'll go ahead and put that in our table right here. It's 3.9. Okay? So with that measurement, now let's go ahead and turn this off, and we'll go back to USB power here. And I'll go ahead and, while I have the chance here, I will put it into DFU mode. And then here, I'm going to leave this delay for 5,000, but then down here, I'm going to do one of the ways that you can put the microcontroller to sleep. So it's system.sleep. And it takes, in this case, multiple parameters, and it will do different things or expect different things depending on the number of parameters you supply. In this case, I'm saying I have to pick basically a pin and say that on the rising edge of this pin, we're not going to use that, but I'm just putting something in there. The third variable is what I'm trying to get to, which is this number here. And this is saying that, and this is in seconds. So this is saying sleep for 500 seconds and then wake up. So that'll give us enough time for us to measure the current in this sleep mode. And again, this sleep mode is essentially this one we're talking about here, which is the stop. And it allows the real-time clock to interrupt us and wake us up. So we'll go ahead and send this down. Okay, so then again, I'm going to disconnect USB, and we're going to connect power. Now what I want to do here is get out of this math mode for now. We'll go ahead and power it up. So for 5 seconds, it's going to be around that 3.9 milliamps, and then it's going to drop down. And so now it's dropped down to 0.054 milliamps or 54 microamps. And that's cool. I mean, that now we're getting to the point where we have sleep modes that can last a long time on a battery. So let's put that in, 0.054. And now let's try the deep sleep. So we'll plug the USB back in, power supply off here, and what we need to do is to get it into DFU mode. And so to do that, I'm going to, because it's sleeping right now, I'll just hit the reset button. When I hit the reset button, it delays for 5 seconds before going back to sleep, so that's my window to put it into DFU mode. And then we'll come over here and we'll comment that out, put the deep sleep mode parameter in. So this is the way you get it into a deep sleep. Okay, so we've reprogrammed it. Again, I will unplug it from USB, set our enable to ground, turn it on. And so we start out in the first 5 seconds in a normal power state, and then we go into deep sleep and look at deep sleep, 0.035 milliamps. So almost half the current, not quite, right? So 0.035, what is this? So almost 35% better, which again, depending on your power requirements and your battery, that could be huge. And so that's awesome that we've been able to measure that now. So the next thing we want to do is look at getting our MCP in the loop and the power that it uses and see how that works. One thing I want to add about the deep sleep mode that we're in right now. So the only way that you can wake up from this is for the digital I/O pin D8 to go high. When that happens, essentially the microcontroller does a reset and starts from scratch. So what's interesting in this is none of the RAM is currently being maintained, and it is as though the processor is going to start over. And that may be fine for our application. So one thing to think about is that our MCP9808 has a feature where we can tell it a particular temperature range that we want to measure, and if it falls below or above that, it generates an alert, which is basically it pulls a pin high or low. And if that pin is tied to D8, then that could be our way of waking up, taking a new measurement, sending it off, and then resetting those high and low bounds, and then going back to sleep and sleeping for a very long time if the temperature hasn't changed. So that's always an option. So we could look at that, or we can just say we're going to sleep, every 5 minutes we wake up and take a new temperature, and that may be fine as well. So we'll explore that as we go through this. So now what I want to do is show you the data sheet for the MCP9808, and I specifically want to go down and look at the power that it uses. And so if you look right here under operating current, it says that it should be using about 200 microamps typically when it is doing measurements. And what's awesome, it apparently has this shutdown mode or low power mode that would be down to 0.1 microamp. So really 100 nanoamps in that mode. And in that mode, we can still communicate to it over I2C and bring it back up to do more measurements. So this is to a point where we almost can't measure that low current on this meter. So let's do some measurements of the MCP9808 and see if they match up to the claims on this data sheet. So the first thing we're going to do is we will uncomment this firing up of the MCP. So what this will do is this will fire up the MCP9808. We won't do anything here yet, and we'll go to sleep, so we'll get that deep sleep current. So by doing this, we'll end up seeing a new power usage of which we can subtract the 35 milliamps and therefore derive how much power our MCP9808 is taking. So what I'm going to do is take this off of the power here, plug in our USB. Go ahead and we want to put it in DFU mode, but we have to have it at least on to do that. So let's do this again. There we go. And okay, so we are in DFU mode. And we're going to go put this code down there. Okay, it has the code, so I'm going to unplug it. The other thing we want to remember is we do have to plug our MCP9808 back into power, so I've just done that. We'll put the enable back to ground. We will turn on our power here and see what happens. Okay, so at this point what's happened is the microcontroller's gone to sleep, but we've left the MCP9808 running and doing continuous temperature measurements. And so we're at about 208 microamps. And so we can put that into our spreadsheet here. And put it in the right spot because we're at the deep sleep mode. And so the delta, if we wanted to measure that delta, so this minus this gives us basically 173 microamps. And according to this, typical is 200. So we're actually better than what the data sheet is showing, which is awesome. Okay? So the other thing I want to do is try out these two power modes to see how these work. So essentially, if I were to uncomment this, once we powered it up and we go into this low power mode, then we should see the low power state of the temperature sensor, and that's when the same one we're going to want it to be in when we also go to sleep with the microcontroller. So again, we'll unplug this and this. We will plug in USB. We will fire up, get us into DFU mode. Didn't do it quick enough. Okay. And okay, so then we'll unplug this, set our enable to ground, turn on power. And there we're at 0.035 milliamps, which is what we would put right here, which is crazy because that is actually the same as in our deep sleep mode. And if this all works, as I suspect it will, we really are sleeping with something barely, it could be a couple hundred nanoamps at that point. And that is really awesome, very power saving. So now we'll go back and let's look at how we can do this. So what we're going to do is uncomment this, and then I'll just go through the code. So I'm going to actually have it run in where we're going to we're going to not go to the deep sleep, but to the stop mode. And we'll let the RTC wake us up every 5 seconds. And we're going to start out with a 5-second delay here, just so that we can, actually, we'll go ahead and take this delay out. So we fire up the MCP 9808, we set its power mode to low power mode, and we don't really want to do that. We want to make sure that our power mode is continuous when we're about to do the measurement. So I'm going to take that out, put it down here, and if you look in the docs on the datasheet and also look at the .h file, you'll find that the MCP 9808 continuous is the one you want to pick here for giving it a continuous power so that it can do the measurement. So we set the power mode to that. We get the temperature. We turn on our radios. We wait for a connection. We wait a slight delay here because I've had issues jumping right from mesh.ready into publishing the temperature, so a little bit of a delay helps. We then publish the temperature. Also, as we go through this code, we see here we have a disconnect and a mesh off. We don't want to do that here. Essentially, once we've done the publish, we can go right into setting our LED to indicate that we've sent something. We can set the power down mode on the MCP 9808, and then we can actually just go to sleep. And when we do that, it'll turn the radios off for us, and then as we come back from a wake up, we can set the power back up on the 9808, get a temperature reading, and bring up the mesh again if it's not already connected. So it should already be there and connected, and so this is just in case it's not there. So we'll go ahead and flash this down. And we can watch this, see it just did a transmission. We'll let it go back to sleep. So it's gone to sleep. Radios are off. It wakes up, sends another transmission, goes back to sleep. Wakes up, sends a transmission, goes back to sleep. So now let's just do that on the external power supply so we can monitor the power. So there we are sleeping at 0.054. Here we're waking up, send a transmission, there's a transmission, now we're back to sleep again. So I'm recording these values, and I'm going to let this run for a minute, and then I'm going to put a USB in here and pull the data off of this, and we'll be able to graph it. So let's take a look at current draw over time. And what I've done here is I've let the system run for basically, looks like almost a minute and a half, and I think this is about the max that I can record on my meter. But what we're doing is just recording current draw over time, and obviously every one of these peak areas here is where we do a measurement and we transmit the data, and then these periods where we see nothing are when we're sleeping. And so we're going to, obviously, when we build the final device and deploy it, this sleep time here is going to get much bigger. We don't need to be doing measurements every 5 seconds for temperature. However, it's nice to do it this way so that we can kind of see the data, and we can always fix the math to figure out how much battery usage we're going to get over time based on much longer sleep times. So one of the things I want to do is sort of jump into one of these in detail and take a look at it. So that's what this next chart is. So here we've kind of zoomed in on one particular transmission. And here we're actually probably reading the temperature, and then we're actually transmitting that data over the 802.15.4 protocol. And if you look at the calculation that I have here, if I look at this over time, it averages 1.2 milliamps, and the average time to do all this is 1.5 seconds, and then we're back to sleeping. And then the third thing is to sort of go back here and look at these guys and zoom in on the sleeps and see where that is. So this is what I've done, is zoomed in on a sleep current and looked at current draw measured over time, and this is 54 microamps. So that's consistent with what we got in our measurements before. So the easiest way to look at how this is going to work with a battery is to go to this very cool website that just allows you to put the numbers in. Out comes a value for how long your battery is going to last. We're going to go to this pretty convenient website called geekstips.com. And here they actually have a battery life calculator that's perfect for the analysis that we need to do. So if we sort of scroll down, we look at the fields that we're going to fill in here. The first one is the capacity rating of the battery that we're interested in. And I'm going to first start out with a 2,000 milliamp hour battery, which I have several in the lab. So that might be an option for us, although I think it may be a little big for the footprint that we're looking at, but it may actually be perfect, so we'll see. And then the current consumption of the device during sleep. So we measured this to be 54 microamps, which is 0.054 milliamps. And then the consumption of the device during wake. So when we look at our graph here, we see that when it's actually awake, and that's what this is, doing the measurements and sending the transmission, we had 1.2 milliamps. So that's what we want to put in here. 1.2 milliamps. And then it wants to know how many times are we going to wake up in an hour. So we're going to do a measurement every 60 seconds. So that's going to be 60 wake-ups. And then every time we wake up, how long is the time we're awake? And so we measured it at 1.5 seconds. So we'll put this in at 1500. So once we put this all in, we do calculate, and it predicts that our estimated battery life will be about 2.35 years, which is pretty good. I'm pretty happy with that. Now, one thing to note is that they do reduce the capacity by about 15%. Other calculators I've used actually do 30%. So just take that with a grain of salt. It's unlikely that you'll do 100% for sure. But I would probably, to be conservative, use a 30% reduction rather than a 15% reduction. So let's try this one more time. This time I'm going to look at a different battery that is a much smaller footprint and it's less expensive, a 150 milliamp hour battery, leaving everything else the same. And if we do a calculate on that, it looks like it'll last 64 days. So that's not enough for a production product. I don't think you want to be bringing it in, every 2 months and recharging it. But it would be good for us to test against this because at least in a short amount of time, I can see how these battery estimates are really working and if we are in the zone for the lifetime we should expect. We could even, for example, up the number of times that we wake up. So if we did a measurement every 15 seconds, that would be 240 here. And then if we do a calculate, now we're down to 31 days. So I'll probably do that in our test just to see if I can get 30 days of battery life out of this system that we build up for the temperature sensor. And I'll come back at that point on the YouTube channel and report what my findings were.